Hello, my name is Sebastian Spirit. I am the lead developer for the PhySim engine, and I will be going over the project for you. So the PhySim engine, a project designed to basically simulate particle physics, developed in under 12 hours for CSGC 2021. We were actually notified about this competition actually about 24 hours ago, yesterday, but of course we had sleep. So the goal of this project was to build a lightweight particle physics simulator with as little overhead as possible. To achieve this, we basically made our own engine for this. We decided that it would be a lot of hassle to actually use something like Unity or Unreal, Love, GameMaker Studio, any of those, just because they have a lot of overhead over them and you can't really control everything that goes on in them. And due to the nature of our project, we thought it would be best to actually just take control of quite literally everything from rendering to the object system, everything like that. So the context, this was used to simulate and visualize different impulses, forces, and currents applied to different particles and their states such as solid, liquid, and gas. Team members, we have me as Sebastian Spirit, engine development, render development, which is mainly just learning OpenGL this morning and writing the entity system and helping out my other teammates with C++ knowledge. Cam Steiner for helping with entities and helping brainstorm many ideas that we used. And Jacob Sharp for helping with entities and helping quite a lot with the liquid and solid physics. So just to go over basics of the project, if we go into the actual entity system here, it's very simple. We have all the entity types up here listed in enum, passed as an int8, so it is only a single byte large. I don't imagine we're going to have over 255 different particle types, so this isn't an issue. And same with entity state. This allows us to very, very easily pack a lot of data into very, very small classes. So here we have our entity class passing pragma pack onto it to make sure that everything is packed as close as possible. So we have 4 byte positions, velocity, 4 byte color, 1 byte type, state, and lifetime, which leaves us with a entity size of 15 bytes, exactly 15 bytes for every single entity, which is extremely, extremely small. And then we have basic constructors, and every entity, every particle will have an onSimulate and onDraw and a shouldDelete Boolean virtual method. To best explain this, we can look at a particle such as water. We can see it has very basic constructor. The onSimulate, very simple. This checks position, sets the position, applies velocity, and increases the position based on the current velocity set in the system. And drawing is, of course, just rendering a very basic pixel. Very simple. This project is very lightweight on the actual rendering side of things. So going into the actual core here, we can see exactly how it works. We're using OpenGL for the rendering. You can find all the source completely open on my GitHub, which will be linked in the description below. Everything here is completely managed in the OpenGL display function, which is kind of like swap buffers, if you know what that is. And to be fair, I've never used OpenGL before this, so my code probably isn't the best for it, but it works for what we need. So the main gist of this is creating a empty clear buffer for the background, which is just black, and then sending a update tick to our entity manager, which then handles quite literally everything, such as spawning new entities, handling the physics, handling different particles such as fire, acid, clouds, and then deleting particles which should be deleted by now. So that is pretty much the engine. Very basic, not a full-fledged engine, but I am proud of what we've done. in this time. And thank you all for watching.